Can you see okay? Whoop. Okay, so the first question is define capacitance. Oh yeah, probably want to see it, huh? Okay, it'll load now in a second. So,
This is too big.
no, it's usually mega ohms. It'll load. Come on, KJ, your grammar is better than that. Now try that again. Yeah, why isn't this? Come on, dudes. Come on, dudes. Here we go. Stuff's happening. Got it here. No, it's not the laptop, it's the projector this time. Oh. Yeah. So, the capacitance is how much charge can be held by the capacitor per unit volt across the capacitor. In other words, as a formula, that's the definition. Capacitance is Q over V. What was your question? No, I don't think it's that warm. Do you?
No.
Yeah, I don't think it's too warm. What do you think?
No.
Fresh air.
Fresh air?
I don't like fresh air.
Yeah. No, she's from China. She doesn't like fresh air. Okay. Are you from a big city? Yeah, so she's from a big city. She doesn't like fresh air. What?
I'm from a big city.
Yeah, but she's from a big Chinese city. So that's a really, really big city. What's the population of your city? How many people in your city? Many, yes.
And that's 5.7 million.
By Chinese standards, that's a tiny city. Please, come on.
Yeah, there's a hotel in China.
That's a village.
That's a Chinese village. Yeah. It's countryside. Alright. Do you have this? Yeah? You got this taken down? Okay. So the... Yes, you have this? Yeah. The B part is a little calculation. So it's 8.5 and 40. So what you have here is capacitor, and the voltage is 40 volts, and the capacitance is 8.5 microfarads. And what do they want first? Charge, is it? So do you remember the formula for charge? CV. Well, this is easy. 8.5 times 10 to the minus 6 times 40. What do you get here? 3.4
Times 10
minus 4 coulombs. So the answer is 3.4. No, 10 to the minus 3 is milli, isn't it?
Yes. 234.
You know what I'll do? Hang on. 4, 5. I think I could change this into 340 microcoulombs if you wanted to. You don't have to. Yeah. Micro is minus 6, isn't it? Yeah. Okay, what do they want in part 2?
Total energy in
Yeah, now this is strange. I don't know why it's not in your notes because I remember doing it in class for sure. I definitely remember doing it. Huh?
I don't remember in class doing series.
For the energy. But I remember doing it. I'm 100% sure I did it.
Yeah, I
In-
remember.
You remember it as well. I don't know where it is in your notes, but anyways,
The
I'll give you the
assignments-
formula.
The assignments we have is here.
You have the formula?
The assignment, yeah, the assignment. No, you gave us assignments.
But still, it should have been in the class notes too. Anyways, look. I'll give it to you now. When you have a capacitor, the energy in the capacitor is equal to a half CV squared.
Like half and
Yeah, it is like a half mv squared. Now, I remember doing this because I remember doing this graph with you in class. And I remember saying that the energy is the area in the graph.
Yeah, I remember that.
Yeah.
It's here.
You have it?
Yeah. Or maybe this is the assignment.
No, this is a homework. Nobody write it down.
Maybe you forgot the formula.
No, I definitely remember doing it.
Then at least one of us should have it.
I can't understand. Why nobody has it?
So it's being due on.
No, I did it in class.
It's before Kirchhoff law or after
Before Kirchhoff.
No.
I don't understand why nobody has it. The only thing I can think of is I did this, it wasn't in the slides, I did it on the notepad. Maybe nobody wrote it down, maybe I went through
Well,
too
it's
quick.
not
Maybe you forget.
No,
Yeah?
no,
We
Maybe.
check.
Right, we will. We will check later, we'll see. Okay, so anyways, that's the formula. So here you have the energy is a half CV squared, which is a half 8.5 times 10 to the minus 6 times 40 squared. So what do you get here?
6 point.
What do you get, Amanda? 6.8 times 10 minus 3 joules.
Yeah.
So the answer is the energy is 6.8 millijoules. Yeah.
I like it.
Huh?
8 times with 10.
Well. All right. Next part. Yeah. So I need to draw this. So maybe you can just help me draw it. What have you got? You've got 4 capacitors and 2 cells. Okay. Yeah. So hang on. There's capacitor, and then
And in the bottom 10 volt.
is this it?
Yep.
Okay. Can you please give me the capacitance here?
4.
4 micro.
Yeah. All the micro.
4 micro.
8 micro.
8 micro.
6 micro.
6 micro and
2 micro.
2 micro.
And 10 volts.
And 10 volts. Okay, so what we should do is combine the capacitors.
Yeah.
Which ones to combine first?
The middle one.
The middle two. So this comes together and it becomes how much? 10 micro. So now what you have is you have a 4, a 10 and a 6. 4, a 10 and a 6. Now how did these combine? Yeah, 1 over, isn't it? So you have 1 over C equals 1 over 4 micro plus 1 over 10 micro plus 1 over 6 micro. So let me see, 1 over C equals, oh my goodness, hang on, I can do this. I'll do this without a calculator. 5 over 20 micro, 2 over 20 micro, no, not 20, 30?
31.
30 micro,
There's no 30.
20, 24? No, 30. 30 is the smallest number, isn't it?
31.
Not 31, no, 30.
My calculator got 31.
No, that's the final answer.
Oh.
No, not 30. 60! Oh, goodness. Right, 60. 60. 60. 15. 6, 10, yes? 25, 31 over 60 micro. So the capacitance is 60 over 31 microfarads. Yeah? Now I don't think that's what they want though. What do they want?
They want the total.
Total energy. Ah, well, this is easy now. Energy is a half CV squared, which is a half 60 over 31 times 10 to the minus 6, and the voltage is 10 squared. So that will be, no, don't need a calculator. That would be 30 over 31 times 10 to the minus 4. So that would be roughly 0.99 times 10 to the minus 4. So what's that?
We got
Roughly 100 microjoules or something. What did you get?
9.67 into 10 minus 5.
9.67 times 10 to the minus 5 joules. Yeah? Okay, next part?
Yep.
Okay, now the next part, you have a what's wrong? You have a capacitor that's charged, and then what's the resistance? Okay, so hang on, 50 micro. Microfarads, and the charge is the charge is 350 microcoulombs, and there's a resistor here, and okay. So they tell you that the charge reduces to 250 microcoulombs after 2 minutes, after 120 seconds. And the question is, what is the OR? So the formula you need to use here is this one. Q equals Q0 E minus T over time constant.
It's not.
Say what?
It's not this wrong.
Not the other one, T is equal to RC.
No, that's the one to use when it fully discharges. But this has not reached 0. It still has a charge.
But they have C, they have T.
Do you have T?
Yeah.
This is the time to decrease from 350 to 250. This is not the time to go from 350 to 0. That T is the time to fully discharge. Yeah? Okay. So here we have 350 micro, nope. 250 micro equals 350 micro E minus 120 over time constant. Cancel, 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 cancel. 5 over 7 equals E minus 120 over time constant. Log on both sides, and they cancel. What's log 5 over 7, Fahad? 0 minus?
Minus 0.0.
Say again, minus?
0.3544.
Yeah. Okay. Equals minus 120 over time constant. So time constant is 120 over this number you just got. What's that, please? going to be like 360 or something.
Yeah, 356.6.
356.6.
6. That's minus.
Two minuses. Now that's not finished because what did they want? They wanted, what did they want? The OR. So now, Amanda, we can use your formula you said, that time constant equals OR-C. So that means OR times C equals 356.6. So OR equals 356.6 over C. So now OR equals 356.6 over...
It's not 356.
It's not.
6. What's it?
120 over 0.35.
Yeah, it should be about 360. What did you get?
338.6.
120 divided by... Yeah, I got 338.
I used the actual value.
Ah,
I used the whole number of the log 5 over 7.
and it made that much of a difference?
You can choose log.
No, I'll just go 339.
You win some, you lose some.
No, it's not like that at all in this case. That would be if you someone typed it in upside down. 339, 339, 339. Okay, what was the capacitance here? It was 50 micro. 50 micro, so that's 339 over 50 times 10 to the minus 6. So the OR equals, now it'll be a big number. It'd be like 6 times 10 to the 6 or something.
6, 7, 8.
6.7.
One sec, yes, sorry?
6.
Yeah, I think that's in the question as the capacitance.
Yep.
Yeah, it's in there. Okay. Right, what's the OR?
6,
6.7
7.
times 10 to the power 6.
Agreed? Fahad?
Yep.
Roughly. So the resistance is 6.7 mega ohms.
You can say 6.78. The rest is zeros.
Okay. Right, now. Can I do the next part? So they want to know, for the next part, how long until you have 150? So again, we use the same formula. Q equals Q0 E minus T over time constant. 150 micro equals 350 micro E minus T over, and the time constant is 339. So this is just like a maths problem. You want to find the T, yeah? So let's simplify here. Cancel. 3 over 7 equals E minus T over 339. You put a log on both sides. They cancel. Fahad, please. This number minus 0. 85, that's it. The rest are zeros.
No.
Okay.
No, not 0. It's a big number.
Well, what's the next one?
84729.
847 will do. 293. Okay. Equals minus T over 339. So we have our answer. T is 0.8473 times 339, which equals seconds.
Minus 287.
The minus is cancelled, so 287.
0.2.
Yeah, 287 seconds. So that's that one. And now the last part, what is the voltage after 5 minutes? So if you want, you can use this formula. So what was the voltage at the beginning? Was 40? Was it 40?
No,
They didn't give it?
No.
Are you sure?
You're pretty sure.
They didn't give you the voltage at the beginning.
No.
So what you could do, that's okay. So what we could do is find something else. We could find the current Q equals IC voltage. Sorry, we need to use a different formula here. Yes, we could use C equals KJ, please. Distracting me. I'm trying to think which formulas we need. We want to know the voltage. So let's go to the side and write down the formulas we know. We have Q equals C over V.
Okay.
We have V equals I or. We have Q equals Q0 E minus T over time constant. And it's the same for I and the same for V. Okay. What could we know? So could we get Q after 5 minutes? Yeah, because do we know Q0? So this is good. Could we get this one? No, we couldn't get this one. But I think we couldn't actually. Yeah, sorry. Could we get this one? No. But we do have C. Now if we have C and we have Q, we could get V. Which is actually what they want, isn't it? So I think we'll use this one and then change our Q into V by using this formula. So we'll go back here now. Q equals Q0 E minus T over time constant. What was Q0 in the question? It was 350 micro. And what's the time? 5 minutes. So what's that? 300 seconds. And what's the time constant? 339. Okay, so can you tell me what this is? This is the Q after 5 minutes. Minus? Oh, there should be no minus here for sure.
Do you have to change it to micro, right?
Yeah, I would like you to put in 10 to the minus 6 for micro. Did you put in the micro here? So you have 144 microcoulombs. Yeah, so the answer is 144 times 10 to the minus 6 coulombs. Yeah? Okay. But C equals Q over V. So that means V equals Q over C. So V equals 144 times 10 to the minus 6 over, what's the C? It was 50, wasn't it? Was the C 50? So they cancel. What do you get? 2.88 volts. Well, this is 5 minutes after the capacitor has discharged. It's actually quite large considering 5 minutes have passed. Is that it for this question? Yeah. Okay. Right.